Hi, and welcome once more to our video series. We are going to talk about the distillation and properties of alcohol lab. And so to start off with, this is also going to be in two parts. So the first part is going to be the lab setup portion, where we're going to think about what is distillation for and how do we go about it, why do we use the equipment that we use, and then we'll talk in a second part about the theory behind how alcohols behave and how they're different from the alkenes, alkynes that we've seen previously. So this guy will scream at me if it gets up too high, so I'm going to try to show you kind of without screams how to set this up. So what you'll need to do is get a ring stand and some clamps. Those are in the bottom cabinets. Those are in the bottom cabinets of the all around the classroom, and those are unlocked. So what you're going to do is you are going to get a round bottom flask, and those are in the blue kits that we have. And you want the size to be so that you are not, it's not, the liquid that you collect or the solution that you collect does not go all the way up to the top. But on the other hand, you don't want to only fill it up a little bit. It needs to be somewhere in between. And a safety issue is to never distill to dryness. The reason being that if there's old gunky stuff or even your own compounds, if you distill to dryness and everything just comes over and you're heating it and it comes over, then you can form peroxides and other kinds of explosives, and so that's not good. So basically, if you don't have enough liquid in your round bottom flask, it can explode. So in general, it's not necessary to work in a hood, in the hood. You can if you want to, especially like spacing wise, if you're trying to find space in the lab depending on how big your class is, but it's not really a requirement. You can if you want. You do need to be by a sink, and so in your head, please imagine that we are by a sink. And what we are going to do is we are going to clamp our round bottom flask, and we are going to have a hot water bath down here. We're going to have a heat source so that we're heating down here. And so hot water baths you can always get set up when you read a lab and you know that in the following week you're going to need a hot water bath when you do the lab. It's always a good idea to get the hot water bath set up, but like right away, right when lab starts. And then what you're going to need is to take this piece, and what we want is to set things up so that everything is as perpendicular as possible. If you start getting weird angles, that's when we can start dropping things. And then this piece, this lovely thermometer adapter. And the reason being is we want to be able to have this, side arm be able to go off and start collecting, our liquid starts being collected. But we also need to keep very, very careful track of the temperature. And so also if you twist things, if you're worried about just, smashing the glassware or the glassware not fitting, if you twist things, especially the thermometer, then things will go in gently. And so I'm going to twist in my thermometer. And I want it to go down so that the tip of the thermometer matches up with the sidearm. So I'm actually not quite far enough. I'm going to twist it a little bit more. Oh, too much. And you want your thermometer twisted so that you can read the temperature. And what you're going to do for your distillation is you're going to be heating this and droplets are going to start to condense. So it's going to be like you're cooking pasta and you're boiling the water, you're getting the water to boil, and you start to see sort of droplets, but it's not really boiling yet. You're going to start seeing that, and eventually you're going to get droplets collected at the tip of your thermometer. And then the droplets are going to start coming over, and that's when you'll start reading the temperature. And an important thing with boiling point, is that it's a range. So it's from the temperature at which you first start to collect your sample till you stop collecting, the temperature at which you stop collecting your sample. So you want a range. It's not just going to be like 54 or 35 degrees Celsius. It's going to be a range. And so another nice handy dandy piece is our condenser. And we are going to stick a hose of inflowing water into the one that's closest, well, it's going to be slightly pointing down, and it's also the one that's sort of the out piece. And then we're going to have a hose that's just for water to leave, that's at the end piece. And so it will look something like this. And I'm going to put a handy dandy Keck clamp on, and I'm going to have the little piece go towards the smaller piece of equipment, and the larger side towards the larger piece of equipment, just to make things nice and tight. So what these clamps are is they just keep our glassware from falling out. So we have things clamped to our ring stand, but then we also have extra clamps, and that's kind of just to make sure everything's in place. It's not going to wiggle around. So, like I said, you will have water going in the far end, kind of the far end, and then you're also going to have water leaving at this end that's close. I mean, it's let's call it the thermometer end. And so you don't need to have the water going on full blast. It just needs to be going through so that you can see water is going through. And then if you touch your condenser, it's a little bit cold. And so the reason for this is that if we have our sample that we're boiling, our sample is boiling, whatever junk that has a higher boiling point is not going to be boiling. It's stuck down there. If there are any holes or cracks or anything, then our sample will it could get lost. And then at the end of the day, we're going to be collecting our sample in this particular simple distillation. We're going to be collecting it in a graduated cylinder. And if everything is still kind of at boiling point, it's just going to go poof, and you will get a very low % yield, which is not what we're going for. So as you can see, my setup is too short. So we can move these things around. This is where teamwork comes in handy, where it helps to work with a partner. I also recommend adding in another clamp just for safety. You know, why not? We have tons of ring stands, so I'd go for the gold. If you don't have ring stands right by your bench top, then just, get them from elsewhere. Oftentimes there are cabinets that no one is using. They're not by anyone's bench top, and so you can always feel free to get your ring stands from a different cabinet. And so I have it set up. Almost last but not least, you can kind of see how it's getting this set up, that we're going to be boiling our sample here. Hopefully whatever else is floating around, the gunky stuff, the garbage, hopefully that has a higher boiling point, so it's not going to evaporate along with our sample. Then it's going to hit the cool water and it's going to start trickling down. Gravity is going to help us. Last but not least, this is going to help us collect our sample, so you can see it ends in a teeny tiny point. This teeny tiny point we can point right directly in our graduated cylinder so that we can collect as much of our sample as possible. everything is just a little bit too low, but it's okay to move things. And it's okay to ask your partner for help when you're moving things, too. So as you can see, we have a simple distillation setup, meaning that we're not looking at fractions. We're not heating things up and letting them cool back down and heating and cooling and heating and cooling, where it's just like a one-time shot where things just go over. And then they're going to get collected in our graduated cylinder. Kind of sort of tricks of the trade are the first drop that comes over is likely just going to be gunky stuff, like if this was not, if there's any point in the trajectory that wasn't perfectly clean, the first drop is likely to be garbage, so you can get like a piece of glassware just to collect the first drop and throw it out, and then the graduated cylinder can be to collect your real sample, or hopefully a more pure sample. And another trick of the trade would be that it kind of helps if you calculate ahead of time how much product you should get, and then it kind of helps you to gauge when you should be about finishing up. Like if you know you're supposed to get 7 milliliters as your theoretical yield, that helps when you start getting to like 6.5, you can kind of start getting ready to sort of turn off your heat source and collect your sample and start to analyze it. And, well, how do you know how much you should get? Stoichiometry, of course. And so go review stoichiometry from your lab, your old labs and your Gen Chem notes, and then come talk to me about stoichiometry, because that will help us to know how much we should be getting. So with that, I am going to let you guys go, and then I will see you again for the theoretical part of lab number 2.